In this video, we're going to take a look at how to calculate volume using the disk method. And in this first example, we have find the volume of the region bounded by y is equal to 1 over x is equal to 1, x is equal to 2, and y is equal to 0, about the x-axis. So the first thing we want to do, just like when we found area between curves, is draw a picture. So we have our graph here. We have y is equal to 0 being our x-axis, 1 and 2 being our two vertical lines, and y is equal to 1 over x, which makes this region here our bounded region. And when we're using the disk method, we are going to need to cut slices perpendicular to our axis of rotation. And our axis of rotation is the x-axis. So we're going to have vertical slices. And when we're using the disk method, the formula is volume is equal to the integral from a to b of pi r squared. So our radius here is from our axis of rotation, which is 0, up to 1 over x. So our radius is going to be 1 over x, and we're going to square that. And then we're integrating from 1 to 2. So we're going to have volume is equal to the integral from 1 to 2, and I'm going to put my pi out front and multiply it last, and then I have 1 over x all squared dx. And now we need to integrate this and evaluate it to find our volume. So we have pi times 1 over x squared from 1 to 2 dx. And then when we integrate this, we end up with negative 1 over x from 1 to 2. And now we're going to evaluate it. So we have negative 1 over 2 minus a negative 1 over 1. So we have negative 1/2 minus a negative 1 gives us positive 1/2, and 1/2 times pi gives us pi over 2 units cubed, because it's volume. In the next example, we have find the volume of the region bounded by y is equal to the square root of x, y is equal to 0, x is equal to 4, and we want to revolve that around x is equal to 4. So when we look at our graph, we have y is equal to the square root of x is equal to 4, and also y is equal to 0, which is our x-axis. And now we're still using the disk method, and our axis of rotation is vertical, so we need to use horizontal slice. And we also need to know our intersection point. And we have x is equal to 4 and y is equal to the square root of x. And I'm going to solve y is equal to the square root of x for x. So I have x is equal to y squared. And it is plus and minus y squared, but because we're only using the positive side, I'm only worried about the positive side. So now I can say y squared is equal to 4 and y is equal to 2 in our case. Plus and minus 2, but we're using the positive side. So we know that we're integrating from 0 to 2. And now we need to find our radius. And because we're using a horizontal slice, we're also going to need to use our x is equal to y squared, because this is going to be in dy. So we have our radius being from 4, which is our axis of rotation, so 4 minus y squared is our radius. And now when we put that into the problem, we have volume is equal to pi times the integral from 0 to 2 of 4 minus y squared squared dy, which is equal to pi times the integral from 0 to 2 of 16 minus 8y squared plus y to the fourth And I got that by multiplying 4 minus y squared times 4 minus y squared, or squaring our terms. And then I'm going to integrate. So I have 16y minus 8y cubed over 3 plus y to the fifth over 5 evaluated from 0 to 2. And now I want to evaluate. So I have 16 times 2 gives me 32. 2 cubed is 8 times 8 is 64, so 64 thirds. 2 to the fifth is 32, so I have plus 32 over 5 minus, evaluating it at 0, and there's a y in the numerator in every one of these, so we're going to have 0. So we have pi times 32 minus 64 thirds plus 32 over 5. And when we do that in our calculator, we get 256 pi divided by 15 units cubed. So in this problem, it's important to remember that our axis of rotation was not the x or the y axis, and we had to account for that by doing 4 minus y squared. In the last example we had, we were on the axis, so we didn't have to account for where the axis of rotation was. It was minus 0. And we can look at that again, as here we had the axis of rotation being 0, so it was 1 over x minus 0. And we simplified it by just doing 1 over x squared. So it's important to keep the axis of rotation in mind when you're doing volume problems. And that's our video on volumes using the disk method.